Hi students. So welcome to this magnetic effects of current part 2. So if you did not observe or if you did not see part 1, please see first part 1 and then you can come back to part 2, right? So here also we'll do some more questions related to magnetic field. Here we will do one current carrying conductor due to circular coil right? So let us see, there is one circular coil is there. This is one circular coil, right? Current carrying due to circular coil, right? So there is one current is there here I. So therefore this is your radius, this is your radius, and we want to calculate the magnetic field due to this current carrying circular coil at certain distance is x. Here we want to calculate, like this is one circular coil is there. So this is one circular coil. So the magnetic field at this point we want to calculate it now, right? So how to do it now? So suppose if the current is flowing like this, so this it will be your current here. So therefore if you want to calculate at this point, so this current is flowing like this. So current is like this, you take the curling the fingers as nothing but a current is like this, this is your magnetic field. So if the current is flowing like this, magnetic field is outward. If the current is flowing like this, magnetic field will be inward, right? So here the current is flowing like this, so therefore magnetic field will be, so it is inward, right? So what will be the magnetic field now here? So therefore by using your Biot-Savart law, therefore we can calculate, so the magnetic field at this point, therefore we can use it, so that is r square plus x square, so this is root, right? Now okay, so I am not going to derive onto this one, so we can see this derivation in a board classes onto this. So magnetic field, it will be equal to mu naught into, so mu naught by 2 into n I r square by r square plus x square to the power of 3 by 2. So this is your magnetic field at this distance. So how I got it now? You might have studied in your board classes or in our video, in our channel also you may expect the board classes of these derivations on this. Okay, B is equals to mu naught by 2, n is nothing but a number of turns, I is the current, r is the radius of this one now, this r square, therefore x, therefore this is your distance from the center of this. So here this is the magnetic field. So still some more modifications we will do it now. What will be the magnetic field at the center? At the center, very very important formula. Center means x value, it will be equal to 0. This is at the center only, the magnetic field will be maximum, right? So therefore substitute x value is equal to 0, r square means r cube. So what you will get it now, just simplify it now, r cube means this r square. So mu naught into n I by 2r will be your magnetic field at the center of your circular coil, maximum, right? So this is a magnetic field due to the circular coil at the center of this one. Clear? So this formula most important, compulsory, you need to remember and you need to practice it, so that right, we can do coming applications now, right? So let us see some applications on this one here. So this is one circular coil is there. So this is a current here, current it will be, what will be the magnetic field at the center? Magnetic field at the center is nothing but a mu naught. I will take n is equals to 1. If any time n number of turns are given, please use that n, multiply of that. Mu naught into I by, therefore 2r will be your magnetic field due to the circular coil at the center. Now, okay, what I will do, I will cut this one now. Therefore, I will take like a semicircular coil. So this is your current So magnetic field at the center we want to calculate So this is half part, it is removed. So therefore, at the center semicircular coil, it will be equal to B naught by 2. So you can write down mu naught into I by, therefore 4r. So what will be the direction? This is a current, so it is inside it your magnetic field now. Clear? So this is a semicircular coil, divide by 2, like that. So 1/4 of the coil if you take it, 1/4 means we can divide this part So 1/4 of the coil I will take it. So 1/4, what you will get it now? So this is 90 degree. So this is your current. So therefore 1/4 means you can divide it So magnetic field at this point B naught by 4. So therefore mu naught into I by 4 multiply it that is nothing but a 8r will be your magnetic field at the center of this. Clear? So now if any angle is there, if at any certain angle is there, so at that point we want to calculate the magnetic field here at any certain angle. Therefore, suppose one part is there. This is important, no? Some part is there. This all the formulas you can get it by using this one, no? Let us see, right? So one small part is there, no? This is one part, current is now. So the magnetic field here, no? It is theta. How to do it now? So the magnetic field at this point, therefore magnetic field is nothing but a theta by 360 into magnetic field due to the complete circle. Therefore mu naught into I by therefore 2r, right? So you can use this one, no? Formula you can calculate. Suppose here angle is how much now? Here it will be 180. So substitute 180. 180 by 360 means 1 by 2. Multiply it. Here how much now? Angle is 90. 90 by 360 is nothing but a 4. Multiply this one, you can get it. So any 60 or anything now, right? Any angle now. So this formula is enough to solve the problems, any type of problems. So also direction, no? Current carrying conductor is like this. This is your magnetic field. It is inside of this. Understood? Clear? Now we'll do some questions onto this one, no? Please, these formulas are enough to solve any type of problem related to this one, no? Let us do one question here, no? So simple question, no? Right? So suppose here one circular coil is there and this is one more circular coil is there, no? Both are concentric circles, no? I is equals to 10 ampere. So another one is it also, it will be about so also 20 ampere, right? So this is inner radius is about 10 centimeter, outer radius it will be equal to 20 centimeter. Now we want to calculate the magnetic field at the center, like this question, right? How to do this type of questions now? Simple, right? So here this is a current now, therefore it is inside. This also current is also inside. Both of they are, it is in the same direction. See, it is inside, it is also inside. Therefore magnetic field it will be equal to therefore B1 plus B2. So what is this complete circle now? Mu naught into I by therefore 2r. So this is, suppose it is I1, this is R1, you can write down I1 R1 plus mu naught into I2 by 2R2. If number of turns are also is there, please multiply with the number of turns. Like this you can calculate it. If their currents are same. If currents are opposite direction, suppose this current is like this, so it is inside. If the current is like this is outside. Therefore which is having more dominating, no? So that in that direction only you have to calculate the magnetic field. Here you can simplify it, no? So here mu naught by 2 you can take it common, no? Mu naught by 2, therefore I1 by R1 plus I2 by R2. So mu naught value is nothing but 4 pi into 10 to the power of minus 7 divided by 2. I1 is nothing but 10 ampere by R1 is nothing but 10 centimeter, 10 into 10 to the power of minus 2 plus therefore 20 ampere current is now divided by therefore 20 centimeter, 20 into 10 to the power of minus 2. What you will get it now? Here it will be 100. So here is also 100. Therefore totally 200. So what you can write it now here? So 4 pi, therefore it will be 2 pi. 2 pi into 10 to the power of minus 7. So 100 plus 100 into 200. So 2 zeros will get it now. Therefore 4 pi, so into 10 to the power of minus 5 Tesla. It is in which direction now? It is inward onto this. Clear? In this way you can calculate the magnetic field due to the circular coils. Now we'll do one more question now. Here suppose there is one circular coil is there now here. One more circular coil here now. This is I1 and another one more circular coil is there. So how it is now? So it is like this. Right. So right. Imagine. So like a right two. Okay, we'll do it now. I'll draw it properly. So okay. Right. Right. This is one more circle. Right. So here there is a current is flowing now. This is I2. So both our radius are same. Suppose here radius is R and this radius is also, suppose it will be, this radius is also R, right? So what will be the magnetic field here now? Due to the circular coil, so it will be toward this direction. Due to the circular coil, so this is a current, right? So therefore magnetic field is inside. So inside like this. So due to this one now, so due to this one now, magnetic field is downward. So both planes are at perpendicular direction onto this one now. So the magnetic field, so due to this one is inside and due to this one is outward onto this. That means it is downward, right? So that means one direction is the, no, this is B1 and another one is nothing but a B2. So what will be the magnetic field? Currents are different, no? Therefore mu naught into I1 by 2R. So mu naught into I2 by 2R. Therefore what will be the resultant now? So these two are like acting, no? This it will be a resultant. So root of B1 square plus B2 square. Magnetic field at the center, it will be root of, therefore B1 square plus B2 square. So B1 is how much now? Mu naught by 2R. Whole square means how much now? Mu naught by 2R taken out. Therefore root of I1 square plus I2 square. You can solve it. You can solve the problems as per given data onto this. Okay, right students. So we'll see like last class concepts, no, and this concept, no, today's class today's class concept, no, we'll do some questions here, no. Let us see here, no, this one concept. So remember only two formulas, no. What are the two formulas? Semi-infinite. So magnetic field, it will be equal to mu naught into I by, therefore 4 pi r. This is your semi-infinite. So magnetic field due to the center of this one, no, therefore circular, no, mu naught into I by, therefore 2r. And one more important formula, one more important point, you should know it. What is that? See here, if there is a current is there now, this is a current is there now, the magnetic field will be more at the perpendicular distance. So along the direction of your current carrying conductor, the magnetic field will be always 0. The magnetic field will be always 0. Therefore along the direction of your current carrying conductors are there, no. So therefore along the direction of your current carrying conductors, the magnetic field will be 0 onto this. Clear? So keep in mind. So then you can solve this type of problems, no. So this is semi-infinite long, no. So here, no, we want to calculate the magnetic field. Can you tell me due to this one, no, what will be the magnetic field due to this wire? So this wire is coming to the center, no. So due to this first wire, so magnetic field due to first wire, no, it is 0. Why? Because therefore we are calculating the magnetic field along the direction of your current carrying conductor. So this one, no, along this magnetic field due to third part, it will be also 0. Magnetic field due to this semicircular part, no, second part, no, this is a second part. Magnetic field due to second part is nothing but a mu naught I by semicircle divided by 2, that is nothing but a 4r. What will be the direction here now? It is inside into the board. Therefore this is your magnetic field. There is no magnetic field due to this. Magnetic field at the center, it will be how much now? It is this one. Clear? Now we will calculate one more, this one, no. Here most of the students, after listening the first question, no, they will think that, can you tell me what is the magnetic field at this first one, no? Most of the students will think that magnetic field due to first one is 0, but it is not 0. Why? So because we are not calculating along this direction, no, we are calculating perpendicular onto this, now, perpendicular distance. So this is your direction of your current, this is your magnetic field. So how much it will be now? Mu naught into I by 4 pi r, because semi-infinite. It is in which direction now? It is coming out. Coming out means like this. So therefore this is third part. So this is a current now. So this also current, this is your magnetic field. So B3, it will be equal to how much now? Mu naught into I by 4 pi r, also dot. Because dot means what? Coming out. Due to this coming out, due to this also coming out. Due to this part, no, it is inside, right? So therefore, so due to second part, no, it is full circle. Therefore mu naught into I by 2r. Clear? But it is inside. So can you tell me these two are to be same direction, no, but this is in the direction. Therefore these to be added, no, because of due to this one, no, you add these two, you will get it as you add these two, you will get it as 2 here, then, no. Therefore 2 means mu naught into I by, therefore 2 pi r. Can you tell me this is B13, right? So can you tell me which is greater here, no? This one is greater, this one is greater. So mu naught I by 2r is there, mu naught I by 2 pi r is there. So denominator is larger, that means this is smaller, this is larger. Therefore net magnetic field will be inside only. This confusion only created in NEET 2019. Most of the students are got trapped onto this. So you need to identify properly which is greater onto this, compulsory. So therefore B naught, right? So it will be equal to, therefore B2 minus B13. So most of the students will, what they will write it, no, this is greater and this is smaller. They will write it, they will take it as opposite onto this, right? Wrong answer. So what you'll get it now, mu naught into I by, this is 2r minus mu naught into I by 2 pi r. What you can take it common, mu naught into I by 2r, therefore 1 minus 1 by pi will be your magnetic field at the center onto this. Clear, students? So very interesting question, no? Right. So one more question, no? Suppose, right, here exactly, so you can try this question, no? This is your magnetic field, it is outward. So this is your magnetic field is outward, but this one is coming like this. Therefore, this is your direction, no? It is also outward. All to be added on to this one now, right? See, observe this one, no? This is one, it is coming out. This one is also coming out. This one is also coming out. Both of this one, exactly the same previous formula, no? Previous answer, no? So this one, no? You will get it as addition here, no? That's all. You can get your answer now, right? So magnetic field at the center, it will be equal to mu naught I by, it will be 2r 1 plus 1 by pi. So please try this question, no? Try this, right? So therefore, whether this answer is correct or not, you can check it. Okay. Now we will do one more question. No? This is one of your NEET question. No? This is NEET 2023 question. Right. So here now, can you tell me what is the magnetic field now? Due to this is inward, due to this is outward, so due to this is inward. Clear? So this due to this one, suppose I will take it, this is one, this is B1 at this point, no? Magnetic field is how much, no? It is inward into this one. No? Therefore, what is this? Semi-infinite mu naught I by 4 pi r. It is into the board. This is outward. This is B2, second part, no? Let us take, no? This is semicircular part. Mu naught I by, therefore 4r. So due to this one, no, it is inside. This is the third part. So B3, how much, no? Mu naught into I by, therefore 4 pi r, it is inside. So these two are inside, this is outward. Now these two should be added here, no? Therefore I will add these two, I will get it as B13, add these two, same thing, 2 multiplied, no? Mu naught I by, therefore 2 pi r. Can anybody tell me which is greater, B13 or B2? This is only the confusion, no? For our NEET students, no? See here, 2 pi means 2 into 3.14. That means nearly 6 you will get it. Divide by the 6. Here 4 r only. It will be only 4. Which is greater here, no? 6 is greater, but is in denominator. Denominator means this one will be the smaller. This one will be the greater. Therefore, net magnetic field was, it is net outward. Right? So these two options are there. Net magnetic field is inside or net magnetic field is outward. Right? So that's why you need to identify it. No, this is divided by 2 pi is nothing but 6 divided by 4. This is smaller. Therefore, it will be the ratio will become like a bigger. No. So B at O will be equal to B2 minus B13. How much now? Mu naught into I by, therefore 2 pi r minus mu naught into I by, therefore 4r. So what you will get it now? Mu naught into I by 2r taken common, 1 by pi minus 1 by 2, net magnetic field will be outward. Please be careful on this one. No? So this question, right? Like this you can expect the magnetic field now, right? So clear? Now also same question now, right? Here this is your current, no? Magnetic field is outward. So this is your current, magnetic field is inside. This is a magnetic field, it is inside. Sorry, here it is inside. Okay. So this is 1. What will be the magnetic field? 1 now. Semi-infinite. Mu naught I by 4 pi r. So due to this one, no? Therefore semicircle. This is second one, no? B2. How much, no? Mu naught I by 4 r. Due to this one, no? It is outward. In which direction now? This is your outward. Outward means like this. This is semicircular coil, no? Therefore semicircle, right? It is inside. So due to this one, no? It is inward. So B3, how much now? Mu naught I by 4 pi r, it is into the board. So you try to see this, due to this one now it is outward, due to this one is inward. Therefore both are cancelled onto this one now. So magnetic field at O, it will be equal to mu naught into I by, therefore 4r. It is net magnetic field is inside. Understood? Clear? So we'll do one more question here now. Right. So here, can anybody tell me? Now remember this. This is one of first part. What is the magnetic field due to this one now? Magnetic field due to the first part is 0. Why is 0? Because this is your current carrying conductor along this direction. So this is semicircular part, no? This is second part. So B2, therefore mu naught into I by 4R, right? It is in which direction now? Therefore outward. Due to this, therefore also magnetic field will be outward. This is 3, B3. How much now? Mu naught into I by 4 pi R. Clear? So this also outward. Why outward? No? This is your current, magnetic field is outward. This is a current, magnetic field is outward. So B at O, it will be equal to B2 plus B3. B1 is 0. So add this one now, mu naught into I by 4R plus mu naught into I by 4 pi R. So what you will get it now? Mu naught into I by 4R, 1 plus 1 by pi will be your answer. Clear? Right. Next one. Okay. So due to this, this is 3 parts are there. Therefore, this it will be about 270 degree. So due to this is second part. Okay. Okay. This is the first part now. Let us take this one now as a first part. This is the first part. Therefore, B1. How much now? It is magnetic field is inside. So therefore, 270 by 360 into. So therefore, mu naught I by 2R. This is only the radius is R. This is nothing but a 3 by 4 into mu naught into I by 2R. So therefore 3 mu naught I by therefore 8R will be your B1. Clear? So due to this part, this is second part. Suppose this is a second part, this is your fourth part. Second part magnetic field will be 0. Why? Because it is in this direction. The fourth part magnetic field will be also 0. So due to this one now, therefore this is only 1/4 part. What will be the magnetic field now? This is your third part. Third part, how much now? This is your 1/4 part now. Therefore 1/4 part means 90 by 360 into, therefore here mu naught I by, therefore how much it will be now? So this is your right, it will be 2 into radius is how much now? This is R and R, 2R, therefore it will be 2R. Clear? So this is 1 by 4 into mu naught I by 4R, therefore mu naught I by 16R. This is your B3. What is the direction here now? Direction is inside. So this also it is inside, therefore into and into. So you need to add it, therefore BO it will be equal to B1 plus B3. How much now? 3 mu naught I by therefore 8R plus, so mu naught I by 16R. Therefore if you want to take it 16, no, 2 multiply it now, 16 you will get it now. 2 3 is 6 plus 7. Therefore 7 mu naught I by therefore 16R will be your B naught. Clear? So this is your into the board. Understood, students? So like this you have to solve the problems, no? Right? So now this is like a 3-dimensional view, it is there, no? Okay. So how to do the 3-dimensional view? So here this is suppose it is a radius is R. Okay. Now we want to calculate the magnetic field at O. Magnetic field at O, this is a current. So this is one magnetic field. Here how it is looks like now. Therefore this is your XY plane, this is your YZ. So this is lying in a XY plane now. Therefore if you take it now, it is outward onto this. This is Z axis means outward. Therefore due to suppose this is your second one now. So B2 we want to calculate B2. How much now B2? B2 we want to calculate how much it will be. So it's semicircular part now, mu naught into I by, so therefore 4R but minus K cap. Clear? So due to this one now, right? So therefore this one part now, this is along the Z axis. This is a current, magnetic field here downward direction. How it is? Sorry, here no. This is here. We'll take it as. This is your Y axis. This is your X axis. Okay. Now this is your current. So magnetic field at this point it will be downward direction onto this one now. Up. This is your positive. This is your negative. So therefore you can take it as like a. This is first part no. Therefore it is B1. What you can write it now? Mu naught into I by 4 pi R, therefore minus J cap. Clear? So this also it will be third part. Therefore mu naught into I by 4 pi r minus j cap. So you need to add it. Okay, so therefore BO it will be equal to B1 plus B2 plus B3. But you try to observe both are acting in the same direction. No, add these two. So mu naught I by therefore 4 pi r into 2 is nothing but mu naught I by 2 pi r. So this B1 and B3 you can combinedly you can write it as mu naught I by therefore 2 pi r into minus j cap plus therefore mu naught I by 4r minus k cap, right? So simplify, you can get your answer now. This is your magnetic field. So therefore you need to try it. So okay, like this different combinations, no, you can practice it. Okay, so let us do last and final question now. Okay, now let us see. Therefore this one, no, it is we want to calculate now. This is angle theta. So this is one is there. So therefore this is acting along this one, no. This one, the one, this is 2, this is 3, 4, 5, 6, 7. You try to observe. This is 1, 0, 3, 0, 5, 0, 7, 0. Correct or not? So B1 is equals to B3 is equals to B5 is equals to B7. These all are zeros. Now magnetic field is created at what point now? Due to which point now? Due to, okay, this second part, fourth part, sixth part. So this is a current, this is a current. So current is like this. So magnetic field is inside now. Therefore B2 how much now? So mu naught. Okay, this is theta is there. So what you can write it now? Theta by 360. 360 means 2 pi you can write it now. It is nothing but a mu naught into I by therefore 2a. This is one. It is in which direction now? It is inside, right? So but here this fourth part, no, it is current is like this, the magnetic field is outward. Therefore B4 theta by 360 into mu naught into I by, so 2 into, therefore what is the distance here now? Radius now, this is a, this is a, therefore 2a. Clear? So in which direction? It is outward, coming out. Clear? So this one, this is larger part is there, no, this is inside. Therefore it will be B6. So theta by 360 into mu naught I by therefore 2 into, what is the distance now? A plus A plus A, therefore 3a. Clear? So it is in which direction now? It is into the board, right? Clear? So you need to add it. You need to this, so you can add it onto this one now. So BO you can write down B2 plus B4 plus B6. So theta by 360 means theta by 2 pi. You can rewrite it as mu naught I by 2, you can take it common. Mu naught I by 2a, you can take it common now. So into, therefore 2a taken now, 1 plus this is 1 by 2 plus this is 1 by 3. Sorry, here no. This is both are same direction, no, this is minus direction. So this should be equal to minus of this. Okay, therefore minus 1 by 2 plus 1 by 3. Therefore which one is greater? You know, this only the greater. Therefore it will be the in this direction. Clear, students? So like this different combinations are there. Some more combinations, no, if possible we'll do in the third part. Okay, but this idea is enough, right? So if you see, if you are not able to understand, please listen one more time slowly, so that you can understand very clearly. Any different combinations they will give, ultimately you have to calculate the magnetic field at the given part, but you have to use ultimately right and thumb rule. That is most important now, right? Okay students, please watch. So first part of this video and second part of this video. So and moving charges also is there. If you three combinedly, if you are able to see it, definitely 1 or 2 questions you can expect in the JEE mains. Okay students, thank you for watching. Please subscribe to my channel and follow my channel.